Why is reusable rocket booster recovery so difficult? Imagine trying to catch a speeding bullet with a tiny net while it's flying through the air at thousands of kilometers per hour. That's similar to what engineers face when recovering reusable rocket boosters. These boosters are huge, often over 40 meters long and weighing hundreds of thousands of kilograms. When they detach from the main rocket after launch, they are traveling at incredible speeds and high altitudes. Slowing them down safely is a huge challenge. You need precise control of their trajectory and velocity, which involves complex engine burns and aerodynamic guidance systems. Once they start re-entering the atmosphere, the real test begins. These boosters face intense heat and mechanical stress from the friction of the air. Even though they are designed with thermal protection systems, they still endure temperatures that can reach thousands of degrees Celsius. The materials used must withstand this heat repeatedly without cracking or burning up. Structural components also face enormous aerodynamic forces that can cause damage if not carefully engineered. Landing the booster safely is another tricky part. It must execute a controlled descent and land vertically on a small pad on land or on a drone ship at sea. This requires perfect timing, precise navigation, and reliable engine restarts for braking and landing burns. The hardware for landing, like deployable legs and grid fins, adds weight and complexity. Every component must work flawlessly, or the booster could be lost. There is also a trade-off to consider. Adding recovery systems and extra fuel reduces the payload capacity. For example, a reusable Falcon 9 booster can carry about 30% less payload than an expendable one. This means mission planners have to balance the cost savings of reusability with the need to deliver enough payload into orbit. Between flights, the booster needs inspection, refurbishment, and sometimes replacement of parts. The heat, vibration, and impacts during launch wear down components. Ensuring safety and reliability for multiple uses involves thorough testing and maintenance, which can be time-consuming and costly. All these factors make recovering reusable rocket boosters a complex puzzle. It's not just about catching a falling rocket. It's about managing extreme speeds, temperatures, and mechanical systems all at once. Advances in materials, guidance systems, and manufacturing have made routine recovery possible, but it remains one of the most challenging feats in space technology today.